everyone, and welcome to episode 2 of New Breakpoint. I am your host, Michelle Sanford. I am the Developer Engagement Lead for Microsoft Australia and New Zealand. If you're wondering what New Breakpoint is because you're tuning in for the first time, then it is a show by developers for developers. And we will release a new episode on the second Thursday of every month except for December and January, which we will have a short break for Christmas. Each hour-long episode will end with a Q&A, so have your questions ready. Why tune in, you ask? We will help you dive deep into the latest developer topics, industry updates, and have exciting demos. And today we are joined by Senior Azure Technical Specialist at Microsoft, Graeme Foster. He is going to help us separate the hype from the code when we are talking about OpenAI and ChatGPT. Graeme will share his personal journey of how he has explored these topics in order to understand what is really important to us developers. Graeme, welcome to the session.
Thanks, Michelle. How are you doing today?
How are we all doing? It's a crazy world, but we are surviving and thriving, I guess.
So it's great to be here today, actually. I did some of these New Breakpoint shows over the last couple of series, so it's awesome to be back and to be showing some code and going into something that is a hot topic at the moment, and hopefully giving people a little bit of an insight into how some of this stuff is working under the hood.
Yeah, in our last episode, we were talking to Mish from GitHub about Copilot Chat and exploring the ways that AI is helping us code in Visual Studio or indeed any IDE. What are you going to be showing us today?
Oh, great. So that's a really topical thing to have shown before this, because we're going to be looking at some of those foundational pieces that allow tools like GitHub Copilot to work. So you obviously can't have moved anywhere without hearing people talk about ChatGPT and OpenAI and generative AI in general. My mum and dad asked me questions about this. My son tries to work out how to use it to help him do his homework, not do his homework, but help him do his homework. And there's a lot of hype around some open source tooling that's being built at the moment. Specifically, there's a piece of open source called LangChain and a piece called Semantic Kernel. And they're really kind of grand sounding names, and they do amazing things. They're allowing people to build like these crazy applications based on OpenAI, which we couldn't really imagine if we were to go back 6 months ago. Now, what I want to do is take you on my learning journey of how I got to really understand what LangChain and Semantic Kernel are doing. And the way I tend to approach these things is I find them a bit nebulous and a bit scary when I look at them from the outside. So I start to kind of imagine the problems that I want to solve using tools like OpenAI and build the smallest amount of code that I can to help solve those problems. It's the way my brain sort of works. And what was really interesting when I went along this journey is that as I faced into the next problem, I realized I was starting to build out my own version of LangChain or semantic kernels. So I found that in approaching the problem that way, it gave me a much better appreciation and understanding of those tools and allowed me to, I guess, take that next leap of thinking about the sort of problems that I could use to solve using those tools. So that's my plan today, is I want to take you through those little small building blocks, show you how these things come together, and hopefully leave you with a better understanding of how these open source tools work.
Oh, that's really cool and really handy. I think I'm the same as you. When I hear about these things, it's impossible to really understand what you can do with them or what the implications are until you start to use them, until you start to try and build things with them. And I went straight into Azure and OpenAI and started trying to do stuff in there. And it wasn't until you mentioned LangChain and Semantic Kernel that I realized that, in fact, there's these amazing tools that can really fast track that journey, which is already fast tracked by the generative AI itself. So yeah, I'm really looking forward to hearing how you dived into it.
Nice, nice. So I'm going to be showing you lots and lots of code today, and if I could give you one warning, it would probably be like, don't try this at home. I found it quite an interesting experience to try and build this stuff out, but my takeaway at the end of the day was that this is done. It's done really well, and there's so many good resources out there that can help you on your journey. But I want to show you how it all kind of comes together, so hopefully you can go away with that appreciation and know how to use the stuff that's already out there on the internet.
I realise that we have mentioned semantic kernel and LangChain quite early on in our discussion without really explaining what they are. Anyone that watched Build will have seen a lot of information around semantic kernel where they talked about the Microsoft Copilots, because it's the middle of it's the orchestration in all of our Copilots. But do you want to just give them a quick overview as to what those two things are?
Yeah, absolutely. So as you're starting your journey with OpenAI and whatever generative AI service you're using, what you're going to find is that there are certain constraints and limitations around what the APIs can actually do for you, which make it difficult to build very, very large, rich applications on top of them purely using the AIs as they are and purely using generative AI. So what LangChain and semantic kernel really allow you to do is to take the AI services as small building blocks, but almost fuse them with more traditional styles of application development to allow you to build much more complicated, rich applications that can leverage OpenAI, but also leverage many existing services that you might have within your environment. And they allow you to build these in small pieces and then plug them all together to create these amazing outputs.
Well, that sounds very simple when you put it like that. Maybe.
Well, and that's the irony of it all, though, Michelle, is that and this is what scared me about the services is when I first started looking at them. My first thought was, well, that's magic. Like the actual way these things work must be so complicated. And I certainly don't want to say that things like generative AI are simple, because there's some amazing technology and maths going on under the hood. But when you actually break down what semantic kernel and LangChain do into small pieces, it actually isn't that complicated, and it kind of breaks down the barrier that might scare you away from using them.
Well, I was just a little bit distracted as you were saying that, because I was thinking back to when I was doing my computer science masters at university. It was 1997. Yes, I am very old. But like machine learning had not even been created yet. We had started AI stuff, and I was trying to build AI stuff, but it was really a line by line, write everything yourself from scratch, until machine learning came in 1997, and this was after I'd already graduated. That was already one leap forward. What happened in 2021, where generative AI came out, has been like a massive jump forward compared to where we were with all that other stuff. And now, yeah, as you say, there are all these little tools that break it all down for us and accelerate our journey even quicker. But maybe you can get into the code and start showing us what we mean.
All right, so we're going to start with a really, really simple example. And what I'm going to do is show you a basic way to use our OpenAI service. So you're looking at a little bit of code here that allows me to query OpenAI and get a response back. Now, the first thing you'll notice is that I'm going to use one of our SDK clients. So this makes it a little bit simpler to call OpenAI. It is just a REST API at the end of the day, but these client libraries make it a little bit simpler. There's some options that we have to pass in that allow us to change the kind of response that OpenAI gives us. So by that, I mean that as a generative AI large language model, OpenAI can be pretty creative if you want it to be. So you can ask it to, increase the kind of temperature, like the creativity of the responses that come back. We can create more randomness in the response as well. So you've got a few parameters you can use to help tweak those models. But when it comes down to it, what we're really doing is we are sending some language, some words into OpenAI. And the model is going to respond back with what it thinks are the most likely terms to come back in response to whatever you pass it in. That's how these models work at their heart, right? Is they are really predictive models where we pass them some content and they make a prediction on what they think will come next. So in my scenario, I'm going to seed the model by telling it, you're a bank teller. So you work at a bank. And what I want you to do is work out what the customer wants to do from the following options. And I'm going to give it some intent. I'm going to say it could be they want to know about account information, could be they're interested in new accounts, new credit cards, branch information. And then finally, I'm going to put the user's input in. So in this case, imagine it's a chatbot or a web interface or it could even be a speech to text where there's a customer talking and we want to work out what they're trying to do. And in my scenario, the customer said, what's the balance on my account? So if we run this piece of code, then what we'll see from the output is a response come back in natural language. It says the customer is trying to get their account information, specifically the balance on their account. So it's quite kind of grandiose, it's quite wordy, it's quite verbose. And if you think back to what we were talking about with LangChain, and semantic kernel, we talked a lot about fusing OpenAI with kind of traditional style applications. Now, I'm sure if you go back to your master's degree that you were working on in AI, you remember we did a lot of work around natural language processing and how we can try to understand language that is passed into a computer, because it's quite hard when you're given a language like English to really turn that into, the ones and noughts that a deterministic computer program might be interested in. And what I mean by that is if we get a response in English like this, it's still, I can look at that and I know they're interested in their account information, but how does a computer know that? So what we find is one of the first things we want to do when we're interacting with large language models and trying to fuse them with traditional applications is we want to try and get a bit more deterministic and a bit more kind of finite in the response that we get back from the model. So how do we do that? Well, I'm going to flip to my next little sample, which is better control over the output. And there's one subtle difference. So all the code is the same, apart from this line here, which says, choose only from the following intents. Respond with unknown if you don't know. So what we're doing now is we're using the system prompt that we pass into the generative AI to kind of be much more deterministic and to really restrict the outputs that come out of it. You might have, I'm not sure if you've seen that little online thing, the Gandalf sample, where it's a little game where you try and cause the AI to break out of the instructions that it's being given. But really behind the scenes, what level did you get to, just out of interest?
I haven't seen that at all, but yeah, I mean, it's prompt hijacking.
Yeah, exactly. Right. So I'm not going to try and hijack my own prompt here, but really what's going on behind the scenes is that a prompt is being built up with more and more constraints put on the AI to try and restrict the kind of outputs that it gives. So in my scenario, I'm just going to run this little bit of code, and we're going to see one big difference, which is that now the output that comes out is just two words, account information. So what we've done is we've taken that verbose language, which would be hard for a computer to really understand, and we've turned it into something that, we can pretty much run like a if then else kind of thing over it. Now, why might we want to do that? What if we don't know what the user wants to do? So let's change this prompt slightly. I'm going to say, what's the color of the fish? Now, this is a bank teller. So imagine if someone walked into the bank and said to the bank teller, hey, what's the color of the fish? If you put yourself in that scenario, Michelle, what are you going to do?
Well, I'm hoping that the person walking in is like a 6-year-old child or something, because if that was a grown person, the bank teller's going to be pretty scared at that unusual, unexpected input.
Could be an interesting situation, right? With respect to my model, if I pass in that query, then the intent comes back as unknown. because we don't know from those four choices what it is that the customer is trying to do. Now, in that scenario, the bank teller's probably going to just sit there and say, unknown. It takes me back to that Little Britain where they used to sit there and the response will be, computer says no. We don't really have that kind of interaction in the real world, thankfully, hopefully anyway. Your bank must be a weird place if that's going on in there. But what would normally happen is that we would respond with something to try and get more information from the customer. So maybe something like, hey, I don't really worry about fish inside the bank, but we do have information about accounts and things like that. So how are we going to get our code to respond with a question like that? Now, what you'll find when you're using large language models is that you can pass more and more into the prompt if you want to. So we could try and make the prompt a little bit smarter and say, choose only from the following intents, respond with unknown, and another question to ask the customer if you don't know. But what I find is that as we try and make these prompts a little bit more difficult and maybe more abstract in how they're going to run, we find that the responses from the models might not be quite as deterministic or quite as succinct as we want them to be. So what we really want to think about is, how can we start to break this up into two prompts? So we might have the first prompt, which is to give us the intent and respond with unknown if you don't know. But then we want to execute a second prompt, which if the response was unknown, we can run another prompt that says, well, hey, how about we come up with something to ask the customer? Now I'm going to refer to these as chains. And it kind of makes sense if you think about LangChain. It's there in the name, right? Lang, language, and then chain for chain. Because the whole idea is that we can take lots of little prompts and start to build them up in chains to create very, very rich outputs. So I've got a little bit of code on here, which is C# code. So I'm a C# kind of person. I like my strong typing in languages. And what I'm going to do is create a little extension method. So an extension method in C# is the way that we can add extra methods or functions to existing things. And in this case, I'm going to add an extension called then if. And all it's going to do is it's going to take a function that will return true or false. So think about it. The output was account information. That's okay. The output was unknown. Well, let's return true or false for one of those. And if the output is true, then we're going to run another prompt through OpenAI. So if we now look at my little bit of code down here, we've got, and let's have a look, we've got a prompt that says, what time does my branch open at? Then if the response intent was unknown, we're going to go and prompt the user for more information. Now, if we look at the prompt for more information, it's just another little prompt that we have inside my code, but it's similar to the last one, but it's got one slight change. And it says, what would you ask the customer next to find their intent given their current input? So let's run this code for what time does my branch open, and we'll see what happens. So the first thing we get back is I've got my little debug. So we're going to see this throughout the rest of the demos where we're calling OpenAI to detect user sentiments, and we've detected branch information. And then my little chain method is going to return false because we know what that prompt means, so we're not going to do anything else. And the output says, what time does my branch open? The intent is branch information. Now, if we change that to where can I catch a fish, then we see we're actually going to return true for my little intent. So we're going to run into the next step. And the output then is, where can I catch a fish? The intent is unknown. And the response is, I'm sorry, but I'm not sure I understand what you're asking. Can you please clarify or provide more information? Now that response, again, doesn't have anything banking in here, but if I had adjusted my prompt to force it to return information about banking and the things that we could do, then it would be a much nicer response to the user. But what you can start to see is that we're building up this slightly richer response to the customer, where we're kind of being a bit more smart about how we are approaching these responses. Now, when we're running applications like this, we're often in an environment where not everything's happening at the same time. So it might be that the customer asks something, we return a response. Then the customer does something else and we return another response. So it's happening over time. And we kind of need a way for our application to be able to keep track of what's going on over a period of time. A way we can do this is by using something that you'll see a lot of in line chain and semantic kernel. It's called memory. So just like you have a memory, I have a memory, when we're building generative AI applications, we can remember things that happened in the past so that we can recall them at a point in time when we need to. So in my scenario here, I'm going to use a very simple memory, which will just remember the conversation that's going on. So I've just got a very simple list of strings, actually. Memories can be very, very straightforward to implement. And the idea is that we can build them up over time, and then we can recall them when we need to. So in my scenario, every time I'm going to pass a prompt into OpenAI, I want to recall the memory of the conversation so far. That then gives much more prompting to the model about what was going on, and we'll get a better response out of the model. What you'll find is that the prompts, the OpenAI models that we're calling, have got a maximum amount of things that we can pass into them. So you might have seen limits like 8,000 tokens or 15,000 tokens. So there's only so much we can pass into a prompt. So often what you'll find with memories is that they're actually like a sliding window where the older the memory is, the more likely we'll forget it. Like me, now I'm getting older, basically. I start to forget things that happened in the past. So it's nice to see that. It's nice to see that the cutting edge of IT works in the same way. It forgets things that happened in the past. So
But is it remembering the exact data? Is it storing the exact data as we input it? Or is it something different that it's doing here?
So my memory is very straightforward, and it's just storing the exact words as they came in. Now, the nice thing about memory is that it's really up to you. So what you'll often find with things like, again, LangChain and semantic kernel is that they will have implementations of memory that might use databases, and those databases might enable you to store things using different formats. I don't want to give too much away on that because that's on the next thing. But there are different ways we can store memories to make it more interesting how we can recall them in the future when we need to. But mine for now is just literally recording the user interactions. So I've got 3 interactions here that happened. What do I want to do? I just don't know. Where can I catch a fish? So obviously a kind of interesting conversation going on here. But when I pass that in and run this piece of code, what we would see is that the prompt that we're building in, passing into the model, is starting to get bigger and bigger with the past utterances that we've had from the customer. And this time the response from the model has been, can I help you with any account-related questions or transactions to that? So it's almost like the model's getting a bit impatient here as the user is trying and failing to tell the model what it wants to do.
We have a queue forming. Can you get to the point? Is that?
That's right. Exactly. Yes. Can't you see? There are lots of people trying to use this service. Now I'm going to take a slight detour here. I'm going to detour to another really important foundational piece of generative AI, which is called embeddings. Now, whenever you're interacting with a generative AI model, there's kind of 2 things that they seem to really offer you as APIs that you can call on them. The first is the prompt, which we've just seen, and that's just the standard, here's some language, give me a response back to it. The second is they can give you what we call embeddings back. And embeddings are fascinating things, and they kind of like blew my mind when I first started looking at them a few weeks ago. So how would you describe an embedding? Well, imagine if you could take a sentence. So you could just write some words down, right? And then you could pass them into something. And that something would say, hey, here are a bunch of vectors. A vector, if you remember back to maths, I had to go back and look this one up. I asked my son, what's a vector? A vector is a number which has a direction. It's something with, I think that's right? Distance and a direction. So imagine if you could represent your words as vectors. So what that would mean is that you've got these models that are trained on, millions and millions, if not billions of pieces of content from the internet. And they have this amazing, I say understanding. They have this amazing structure that kind of encapsulates all of these connections between words and phrases and sentences. And the models are basically numbers. They are billions and billions of numbers. So if you could take your words and represent those words as numbers with direction, where semantically similar words had similar vectors. So think about hot and cold. So you might have a vector space where hot was pointing up for a distance of 5 and cold was pointing down for a distance of 5. So you'd have up 5 and down 5 representing hot and cold. You might have boiling hot, that might be up and 10. You might have freezing cold, which might be down and 10. So you can start to see how we can embody words as numbers with directions. And then you could also, because numbers and directions are not language related per se, they're not English, right? At the end of the day. So if I say 5 up, that could mean hot in English. It could mean should in French. If I say boiling hot is 10 and up, that could be très chaud in French. That could be 10 and up. So embeddings are not actually fixed to language, which is super, super interesting. So you can use a large language model to pass in some text and get a bunch of embeddings out of it. And they literally come back as numbers. So when I call my model and say, what time does the shop open at? Here is a representation. This is just the first 20. I think I get about 1,000 back or so of numbers that represent that in this kind of different way of looking at words. So
it's such a complex topic. It's really difficult for people to understand how like it's at the same time complex, but also really, really simple. I like to think of it as like a massive mind map, but instead of that mind map being on the page, it's multi-dimensional. It's more than 3D, and it's more than words, as you say. It's all sorts of unstructured data, I guess. But the embeddings are turning them into numbers. It's not encryption exactly, but it is like that concept, and the computer can process those chains of numbers a lot more quickly and easily than it can understand all of these mappings, relationships, and what all the things are. But because it is this massive mind map and it's crunched it down to these tiny little codes, it's just so much more efficient.
Yeah, right. And you start to say, well, okay, great. Why are you showing me embeddings? Why do I care that we can represent words as numbers? And it turns out there's a really, really important reason why embeddings are super useful. And I want to demonstrate that by showing how we can use them to create amazing search experiences over unstructured data. Now, imagine this, right? Imagine that you have a document that is 20 megabytes long, and it's got a whole bunch of useful information inside it. And you want to use a large language model to chat over the information contained in that document. So the question is, well, how are we going to do that? Because the prompts sizes that we're allowed to pass into the models are not big enough to allow us to pass a 20 megabyte content in there. So if we want to enable a really, really good search experience over all this unstructured content, what about if we could take that content and we could turn the content into embeddings? And then as the user is chatting, we can turn the user's conversation into embeddings. And what if there was a way to somehow search over embeddings? Now, this gets super powerful, and it turns out there is, and it's actually, what's the name for it? It's cosine something or other. Again, I'm not really a maths person at the end of the day. It's where you want to talk to your data science types. Cosine similarity. And what it is it's a way that you can take one embedding and you can then use this function to say how similar is it to another embedding. So what we can do is we can start to express our documents in terms of embeddings, and then we can make a search over them by saying, out of all of these embeddings, which is the most similar one to the content that the user has passed in. Now, when we want to create embeddings for our documents, we can't just create a single embedding for a 20 megabyte document. The models just don't work in that way because there's a fixed amount of numbers that can come out of the prompts and the embedding functions. So we need to start thinking about breaking our documents down into smaller chunks. And there's a little bit of a science that's starting to grow up here, which is called document cracking. And it's literally a way that we can take big unstructured documents and we can break them into small enough chunks that we can pass into the models to get the embeddings out of, whilst keeping the maximum amount of meaning inside those small chunks. So what I mean by that is, one way you could crack a document is just to count 100 words and go and create an embedding, count another 100 words, go and create an embedding, and store these somewhere. And that's okay, but you might find it's better to have the section name in each embedding. It might be the title of the document's important. So there might be other content, images, which you want to get information out of that is actually really useful to create a embedding that is going to be the most optimal for searching over. So there's a lot of things starting to appear to help in this space, like Microsoft have got something called prompt flow, which is a way to create embeddings over documents and then test them against the kind of queries that you're going to be searching over to make sure that they are working as good as they can. But the general idea is that, we break them into chunks, we store these embeddings somewhere where we can run a vector search over them, which is a search that compares the embeddings. And that then potentially gives us a good output. Now, more and more databases are starting to get support for vector searches. So Microsoft's Cognitive Search has got it. Our Cosmos database has got vector indexes in there now. And I think we're seeing more and more pop up. I'm sure Postgres has got a vector plugin as well. So what I'm going to do is I'm going to show you some searches over a couple of documents. Oh, I haven't got my documents up, actually. That's a shame. But I've got two very simple text documents that I've loaded into a vector index. One shows me the opening times of some branches, and the other document has got the colors of the rainbow inside it. So two very, very, very different documents. And the first thing I'm going to do is I'm going to run a query that says, what time does the shop open at? So to make this work, I'm going to ask OpenAI to get the embeddings for this language. And then I've got a little function that's going to search using Azure Cognitive Search over that index. So we're going to run that. And whoopsie, there's my first error. That's okay. So here we go. So when we run what time's the shop open at, we get back the document that has got all of my opening times inside it, which is awesome. That's what you would expect. If we run what are the colors of the rainbow, then the document that comes back is the colors of the rainbow are red, orange, yellow, green, blue, indigo, and violet. But what's really, really interesting, and I have to admit, I haven't taken this idea too far, but the science sounds pretty sound to me, is that because embeddings are not coupled to a language, we're just really searching over semantic meanings. Then what about if we were to ask for the embeddings in French of a question and then run that against our search index? So here I've got my GCSE French from England coming into play. À quelle heure ouvert la magasin? With my heavy Burnley accent on top of it as well, just for more fun. So we're going to ask in French, what time does the shop open at? We're going to get the embeddings and then see what happens when we run that against the search engine. So we get back the document we would expect, opening hours. So that's pretty interesting. Just to make sure this isn't like a one-trick pony kind of thing, here's the next query in French. Qu'est-ce que les couleurs dans un rainbow? And if we run that, then we get back the second document. The colors of the rainbow are red, orange, yellow, green, blue, indigo, and violet. So this is really interesting. So now we've been able to take large unstructured amounts of content, break them into these small chunks, create embeddings for them, and then take some user input, potentially in a different language. And what I found is that, this works really well if there's a lot of content that was in that language on the internet. So French, Spanish, Japanese, there's a myriad of languages, most kind of main spoken languages that it will work really well for. If you're trying to converse in Klingon, there could be quite a lot of Klingon on the internet as well, thinking about it. If you're trying to converse in Latin or something like that, maybe it's not going to work as well for you.
So you're not having to train it in any of those languages. You're just asking it in one language and it's coming back in English each time. But if you told it to come back in a different language, it could do that too, right?
Yeah, right. So that's the other side of it, right? So here we're just asking for the embeddings of an input. So if you like, there's almost this intermediate language, which is embeddings. If you think of it, it's a bit like, Esperanto. If Esperanto had really succeeded, maybe that's what embeddings are instead, is this idea of a common language, a meta language that can represent any language. And it allows you to translate to it, but then translate back out into a different language. So I think this is one of the really cool things that Google Translate did. I think this is like one of the really cool things Google translated back in the day, where instead of having translations from language A to language B, everything went to an intermediate representation, and then every language had a translation to and from the intermediate. And that then gives you translations between every language. So pretty cool stuff. Okay, so we're going to flick and show how we can start to incorporate these vector searches into our chains. So if you think back to the chain earlier, it's pretty straightforward. It was really just calling methods on our REST OpenAI APIs. But what we're going to do now is we're going to incorporate this idea of an unstructured search engine into the chains as well. So I'm using my friendly little extension methods again, and this time we're going to say, well, look, get intent, what time does my branch open on a Friday? We've got the then if that we had earlier. And this time, if we understand the intent, then we're going to go and get the text embeddings. Then we're going to do a cognitive search. And then what we're going to do is we're going to take the output that comes from the search engine. And we don't necessarily want to present that straight back to the user, because there could be other things in that block of text, depending on how the crackings have worked. There might be other information that's not relevant to the conversation. So we're going to call another query on OpenAI. I've called it present results here. And what it says is, hey, you're a bank teller. Extract the relevant content from the excerpt below and summarize it. Only use the content if you do not know the answer and explain why. And then this lovely little bit on the end, you must respond in the user's input language. So let's run this one, and we've got what time does my branch open at on Friday? So the chain's going to run through, and you can see we've kind of come through to execute the search against the vector index, and we're going to call OpenAI, and it tells us your branch opens at 8 o'clock on Friday. And going back to this idea of these intermediate languages, what's super interesting is we can actually make a call in French to that with « Quelle heure ouvre la salle à vendredi ». Hopefully you don't get too many complaints about my French accent. And when we run that one, what happens is the response comes back in French. La salle est ouverte le vendredi de 8h à 15h. So it's not only understood the question in French, it searched over English content and then presented the results back out in French to me. Now you think about global companies and the amount of unstructured documents they must have in English. And if you're coming on speaking a language that's different and maybe aren't so proficient in English, this could be an amazing thing to be able to just search over all of this content using your own spoken language.
Well, I think 10 years ago when they were talking about big data, we thought that was going to be the answer to everything because we had the data and we thought we had ways of doing stuff with it. But this really is helping us crack into that data and access it, in a way that we couldn't have done 10 years ago.
Yeah, it's amazing. And there's so much stuff happening in this space at the moment as well. So it's just going to get better and better. Now, I want to move away from unstructured data. So they are one thing, but you think about most organizations, and especially over the last 10, 15 years or so, there's been a huge rush to build APIs. Like the API economy, APIs are eating your lunch, you name it, we've seen it in headlines. And now what we have is organizations that have got gazillions of APIs that can be called to get useful information. They're very structured. They're very different to the kind of documents we were just looking at because they have very particular ways you have to call them. And the output that comes out of them is very much data. It's not language like your documents might be. Now, a few weeks ago, our Azure OpenAI service inherited one of the features that OpenAI has had for a little bit longer, which is called function calls. Now, these are very, very cool. Imagine if you could take all of your APIs that you have, and what you could do as you're interacting with the generative AI models is you could get them to sort of tell you, I think that API would be a good one to call to help answer the user's queries. And here is the data that you should be passing in to make that API call. Now, doing that allows us to define, we can create these function definitions, and using the SDKs, we can pass them into our prompts. So in my case here, what we're looking at is a function on an API called get account information, gets your bank account information. It's very important to be very descriptive when you're declaring functions to OpenAI because the thing is like a large language model. So the only way it really knows is through natural language. So we use descriptions on parameters and calls to help the model understand what this call actually does. We define them using JSON schema. A lot of people apparently don't like JSON schema. That's, but whatever your take on that is.
They are wrong.
It's just the way the models have been trained, basically. So I think OpenAI trained the models to understand JSON schema and to be able to do this. So we've got properties, we've got an account number, and we've got a service in this case, which can be balance, details, payment schedules, or unknown. So let's have a go. So I've got a little prompt here that says, what's the last payments on account? So we're going to make a call, and we'll be passing the function definition into OpenAI. And what we're going to get is that we have got a service. It's detected basically a service called payments on the function called get account information that it thinks is useful to call. Now, that's okay, but it doesn't have all of the parameters in that we need. If we say, what's the last payments on account 1, 2, 3, 4, 5, 6, 7, 8, then what you'll see is that the account number comes back inside there as well. So it can look at the context and it can work out what the parameters are that we need to call the method. So this is really, really cool. But again, just like when we detected an unknown intent, what if we don't have all the parameters in there? We kind of need to be asking the customer to provide the additional information so that we can help them. So I've got another example here, which I've called Bring It All Together, which is, if you like, the really, really big example that I've got. And this is using a chain again. So, we get the intent. If it's unknown, we prompt for more information. If it's branch information, we're going to use that little search that we have, get text embeddings, then search, then present results. If we're checking for account information, then we're going to try and get the function called parameters. But if we don't have enough, then we're going to use a similar prompt to ask for the extra information. So what we'll do there is we'll basically say to OpenAI, hey, we're trying to call this function. We need these parameters which have these descriptions. Here's what the user has given us. Can you tell me what to ask them next? So again, we're going to use the models for where it makes sense. If we get all the information, then we're going to call the function, and then we're going to present the results back in a nice way, just like we presented the unstructured content back. So there's a lot of code here, right? I totally appreciate that, but it's pretty powerful. So if we call with a few of these examples, let's start with what is the balance on my account? And what we get back after we execute all of the prompts, and we're going to detect we don't have enough prompts, is, I'm sorry, but in order to provide you with the balance, I need some information. Can you provide me with your account number or your name? I like the or your name bit. See, this is where the model's hallucinating a little bit. We refer to hallucination in models where they kind of like go off script a little bit. They invent things. You know, you might have seen this if you've used ChatGPT. And it's because my prompt isn't strong enough. It's not firm enough to really constrain the model in what it needs to do. But that's okay. Let's try a different prompt where we have that information. So we'll say, what are the last few payments on account 1, 2, 3, 4, 5, 6, 7, 8, 9? So we run that one through. And here we go. The last few payments on your account are as follows. So this has now worked out that we have all the parameters. It's gone and called an existing API that we have. And now it's presenting those results back out to the customer. So again, pretty exciting. But just one of my favorite ones is in Spanish here. So again, I'm going to embarrass myself with Spanish here. So, ¿cuál es el saldo de mi cuenta? 1, 2, 3, 4, blah, 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 blah. So this is basically what is the balance of my account number 1, 2, 3, 5, 6, 7, 8, 9. So we pass that in. It's worked out that it's account information. It's worked out that it's got all of the parameters. It calls the API, but it then goes and responds in Spanish. El saldo de tu cuenta, blah, 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 es the blah, blah, blah. So I think that's like really quite amazing that you can have these legacy APIs. You can converse in a different language to all of your content, and yet you can still create an immersive experience in different languages. But there's a lot of code. There's a lot of code here, right? These chains are starting to get really big. And if you had lots of different things that your model could do, then you can imagine these chains would just grow out of control. And that's the last thing I want to show you. And this is what is really special for me about LangChain and semantic kernel, is that they both have got a concept of, it's called plans in one and it's called agents in another. I can't remember which is which. But the idea is that, you know, we've got the model doing everything here. But why do we have to create this structure of the order in which things must be done? Why don't we let the model do that? So the idea of a plan is that we can take all of these little building blocks of capabilities we have. We can search the account information. We can search the branch information. We can call APIs to get account balances. We know what the intent is. If we can create a prompt that can tell OpenAI all of the little things that we can do, all the building blocks we have, and then tell it what goal the user is trying to achieve, it should be able to actually create a structure in which we should call these little building blocks to achieve that goal. So I've got one here where basically, and you should look at the prompts for these. They're all inside the GitHub repositories. The prompts are quite amazing to actually create these chains. They're very special engineering. That is a science in itself, is crafting prompts to pass into large language models. But here we go. Given a goal and an input, you must output a plan how to achieve the goal given possible skills. Everything's in JSON. All inputs to skills must be populated. Like, there's some groundings for the model. And then we're going to give OpenAI, we'll tell it what we can do. We can summarize content. We can call a cognitive search vector index to search branch information. We can get embeddings. So we can call cog search. We can extract key terms, and then we pass the input. You're a bank teller. The user will ask what interest rate is on your transaction account. So that's all we're going to pass in. And if we call that, then the output that comes out is pretty cool, in my opinion. Again, I haven't really practiced this in the real world, but prompt chain, semantic kernel, and LangChain have both got support for this built into them. So I get told that the first thing we want to do is extract key terms. The next thing we want to do, now these are a bit actually turned around. My prompt's not that great, but it wants to call a cog search vector index function. But if you look, it's going to pass in some search text and some embeddings. And the embeddings are coming out of number 3, which is here. And then it's going to summarize the content. So in essence, it's taken these little building blocks and it's managed to give me a sequence in which I can call them, where it tells me what inputs to pass into which one and which outputs to pass into which one, to be able to create the experience so that the user can fulfill the goal that they're trying to achieve. And that's like, for me, that's next level. It's like, wow, this is crazy. Like all of that code in number 9 here, and really we can use plans and agents just to get rid of that and turn it into like one query to the model. So that's pretty much in a nutshell, Michelle, my kind of journey to realize that I was building my own version of the LangChain and semantic kernel that was never going to be as good, but certainly distilled all of those concepts so that I really had a good understanding of what these 2 open source tools actually are doing.
That's amazing, Graeme. I don't think that I would go that far in order to understand these concepts. I think probably I'd go the next level up and try and build things using them in order to understand those concepts. And definitely I was delighted when I saw them, because I thought I have been trying to code this stuff myself. And here it is. Here is this orchestration. Here is this chain to sort of, map all the things together and make it easy for me. I can't wait to build stuff with this and see where we go. We have definitely gone really deep on this and spoken for a really long time, but is there anything else that you think we could share that we haven't had a chance to, that is your sort of, top takeaway from this session?
Look, sorry, things are popping up on my screen. Look, for me, it's a case of really, I think the power to being able to leverage OpenAI and tools like LangChain and semantic kernel is to have that little bit of an understanding in what they do. But to your point, it's about just thinking of crazy ideas in which you could leverage these things, because there are so many use cases that I think we haven't even thought about, haven't envisaged yet, that are going to start to happen over the next 6 months or so. A lot of people at the moment are, they're writing little MVC applications that allow you to search over existing data, and that's really nice, but I think that's the tip of the iceberg, and I think we're going to see some crazy advancements. So understand the technology, kind of know how it works, and I think that'll give you a really good grounding for the coming couple of years where this really starts to explode. And don't try and write your own LangChain or semantic kernel. That's probably my bigger takeaway. These things work in a variety of languages, so as long as you're in the Python, TypeScript, .NET space, and I'm sure there will be others out there that I haven't looked at, they've got your back, you're covered, and you don't have to go and suffer like I did to try and make all this stuff work.
Yeah, I mean, although there are traditional languages that are definitely more associated with data science and with AI, I think that the Copilot, GitHub Copilot is across all of the languages, and so the other languages will follow very quickly.
Yeah, absolutely. Hey, I was doing an example a few weeks ago and got Copilot to explain some PL1 code. And, even languages you think there might not be that much of on the internet, there turns out there's, enough to give these models a grounding in them. So I'm not saying someone's going to write LangChain to PL1. That might be a bit out there.
But maybe if they're as crazy as you are, they might just do it.
There's probably someone out there, actually.
Well, that's awesome. Graeme and I are going to stick around and answer some questions for you, so go ahead and put those in the chat. Thank you for joining us today, Graeme, and I look forward to seeing you again.
Thank you, Michelle. Thanks for having me. I really enjoyed it. Thanks.